Yeah, hello. Whilst I'm carrying out all my repairs, or attempted repairs, but they're mostly successful, I keep all the faulty components in my graveyard box. I don't know why. I mean, I was repairing and designing, but I've always had a graveyard box, which I put things in, and then when I'm designing stuff, I just go through my graveyard box and just see what's failed, and then think about why it failed, or if there's an explanation. You know, sometimes there's no explanation why a component fails. It might just be a weak one out of the batch, wasn't made properly. It might be a weak design, but as you repair more and more of the same thing, you see the same things failing, and then you start to draw conclusions as to why they have failed. So I thought, you know, we'd spend 10 minutes, 15 minutes just going through the graveyard box to see what's in there, what I've changed in the last. This one is dated 16th of the 12th, 18. So it's now end of January, beginning of February 19. So it's probably about 6-7 weeks worth of failed components in here. So should we have a look, see what's inside? So we pull the lid off, and now you can see everything that's failed. These are confirmed failures. If I think they're okay, they go in a different box. They go in the probably okay, condemned unfairly by me box. Right, so that's a switch, so we're not going to bother with that. That's just a broken switch, broken inside. So the little lever that actuates the way it's gone inside the switch is broken off, so the switch wasn't making contact when you pressed for the contacts. So faulty switch, the front control panel of a spark erosion machine, no good. There's the plunger for it as well. Get out of the way. Yeah, that's a mounting board for a Bose Wave CD player, CD laser, to rob a laser from one to fix another one, a scrap one. So that was a CD laser repair. Capacitors. You know, if you'd looked in this box probably 10 years ago, during the very bad capacitor plague of the late 90s and the early noughties, you'd have found an awful lot more of these capacitors, electrolytics. These days, you don't see many that fail. They're actually very good compared to what they used to be, because I remember the Dell computers and all the Samsung TVs falling over like flies, dropping like flies, due to bad capacitors. And the story was that Nichicon and Fujicon used a formula for the liquid inside the electrolytic capacitor. Obviously, inside here they're electrolytic. There's an electrolyte and foil and an absorbent dielectric foam stuff, paper perhaps. And the story that I was told was that the Chinese factories had stolen the formula for the electrolyte from Fujicon. But what they didn't know was that Fujicon never wrote down all the ingredients. There were ingredients in there which weren't documented, which were designed to stop the electrolyte deteriorating and gassing over time. And what happened was the Chinese made all these capacitors, and Dell and everyone bought them. Even my Samsung freezer failed because of a Chinese capacitor, and my Hotpoint freezer in the outhouse failed as well due to a capacitor. And it was these Chinese capacitors had the stolen Japanese formula in the electrolyte with the ingredient missing, which stopped them drying out. So subsequently they all dried out, and they either went short or went very low capacitance. So it was the capacitor plague. It's not widely spoken about, but certainly in the industry which I was in, which was making computers, it was a well-known fact that, you know, there was a huge problem, and Samsung flat screen TVs were particularly badly affected in the power supplies. If you look on eBay, you'll see loads of people selling refurbished Samsung flat TV power boards, and they just change all the caps. And of course, you know, from the 70s, I've got amplifiers from the 70s and 80s, which the caps are in great condition, but then they went through a really bad phase in the 90s and the early noughties. So yeah, electrolytic capacitors, not many in here. There's one. This one came out of a Bose unit that is from Africa. and clearly the generator had gone wild and over voltaged it, and that's the result. You see the top was domed, it was about to explode but didn't quite get that far, and that's a Nichicon, so they didn't fail because of any old age or anything else. So that failed due to an over voltage situation, probably from a bad power line or a bad generator. Okay. Panasonic lithium battery from a Hewlett-Packard Agilent signal generator. That's just a lithium backup battery, which was flat. So that was 1986, that test equipment. So that had been running until, well, December, and the battery went flat. So I just changed that. That's just a flat battery rather than a faulty component. Here's a varistor. You know, these things which are designed to protect your semiconductor devices in the event of a failure. You can see this one's well scorched and been subject to an overvoltage. Now these things, these metal oxide varistors, they deteriorate. You know, if you hit them with a decent pulse of high voltage, they conduct it, and they conduct a lot of current as well. When the voltage across these terminals goes above a certain amount, they start conducting. But yeah, as you hit them time and time again with a transient, they get destroyed. They deteriorate over time, and they can either go completely short circuit and blow up on their own, or probably, as in this case, either lightning, power surge, or a generator surge. Okay, so that was they're not a great form of protection because of the fuses, which are any fuses in here I can show you. Yeah, here's a fuse, look. So I think in this particular equipment this came from, this fuse, can you see that? Is that in focus? Don't think it is it? Let's go manual. The other way. Yeah, so that's how many amps is that one? 5 amp fuse, okay. 5 amp fuse, power comes in through a filter, through the 5 amp fuse, through a bridge rectifier, and this is across the input of the bridge rectifier. But these fuses are slow blow, and if you look at the data sheet for these, I've done this in some of my videos, looking at the data sheet, these fuses are a subject in themselves. I'll go over it one day, but they are capable of sustaining, this is a 5 amp one, can sustain a much higher current than 5 amps for quite some time, certainly enough time to destroy everything in its wake. Okay, let's just switch to macro mode, shall we? You can see a bit better what I'm talking about. So where are we? There you go, that's better. So 5 amp fuse there. So these blown, not good, not good. What else have we got in here? Let's move the thing. Should we go fishing? Let's do a lucky dip, shall we? There we are. Yeah, look, this lot represents 4 or 5 weeks repairing all the necessary stuff that had to be done to get these buggers to give up their secrets. Oh look, here's Class D amplifier. Class D amplifier chip. I think it's 50 watt Class D. It's I think it's a TDA 7293. Yeah, these are particularly interesting actually because they rely on a plus or minus DC voltage supply, and if the negative or supply rail goes, it blows the chip up. So if you lose one of the supplies to the device, it destroys the device and it goes into high current mode. It doesn't work. Otherwise, it's pretty reliable. I think usually what destroys these chips is a failure in the power supply. Power supply fails, one of the rails disappears. Goodbye chip. About £5 each. Come in 2 forms, either with legs straight out or the right angle legs. Make sure you buy the right one if you're buying one of those. But quite a common chip. And this is used in HF driver circuits for JBL powered loudspeakers, amongst other things. Okay, so bunch of relays, latching relays. Anybody that hasn't seen how latching relays work, these are latching relays, and you put the power on, they latch in one position, you hit them with the power again, they unlatch. Okay, so you have to put power on to latch and unlatch them. And these are relays which are in the input voltage detection circuit of a high power audio amplifier, and they switch in, there's a comparator circuit which switches in a voltage doubler using this and holds it in. But if they get stuck and the voltage doubler is switched in, but you are in 230 volts input or 240 volts input, it just completely fries all the electronics. They just get completely blown because it's working as though there's 110 volts coming in, and in fact there's 220, and it doubles the voltage, and bye-bye capacitors, such as this one. Okay, that's the sort of thing that happens. Plus all your power transistors and your switching circuitry and a lot of other protection devices are all screwed. Right, so a whole bunch of relays, and they're out of various amplifiers and stuff. So shove all the relays. There's another one. So that's another relay out of a power detection circuit as well. So another relay blown. So this relay, because they are, why do they blow? I don't know really. You know, you could argue again it's something coming down the mains causing them to go kafooey. We never really know, but when you change them, they're okay. But very annoying to have, you know, £500, £600, £700 amplifier blown up by a 50p relay, to be honest. Not a great fan of contacting relays unless you really do the reliability test on them and get the ratings correct for them. Okay, so relays, a whole myriad of, what's this one? That's an FQP P channel, FET audio output transistor, blown. Another one blown, another one blown. You can see how many audio output transistors have gone, and drive transistors from power supplies. All these are FETs, P and N channel FETs that are all gone for a Burton. We say in England, gone for a Burton. Let's make a pile. You can see. There they are. Somebody was enjoying their music, and then suddenly they weren't. This might be in a bad smell. And output transistors, 7N60s. Look, these little chaps here. See those 7N60s? Lots of those, probably a dozen of those. Okay. Power inductor, open circuit. Quite a lot of buck regulator power supplies. You know, they rectify the mains and then they take a DC low voltage via the buck regulator, which is basically using an inductor, injecting the power in the inductor and using the inductors as an impedance to drive the low voltage side. So you can get you know, 250 volts, 240 volts AC in, 360 volts DC when rectified, goes into the chip, into the inductor, and from the inductor there's a diode and a capacitor. So when this is working, it's got 360 volt peaks on one side and say 20 volt peaks on the other, and the insulation breaks down. And you can get high voltage ones of these, but people in these amplifiers, because of the European Union regulation on standby power, the old amplifiers just used a, you know, or TVs used to use a train of resistors to make the low voltage DC for the thing was in standby, and that would be the thing to power your LED. Excuse me a moment. Yeah, that would where was I? Yeah, and so this is a more efficient way of dropping the mains voltage down to a low voltage DC power to either power your switch mode power supply DC control electronics, or some kind of standby electronics. But the problem is that between these contacts, when there's another one here, look, when these things are firing and working, there could be 330 volts across these two contacts, and where that wire goes in there, can you see that where it's all scorchio? They arc across. That one's been arcing across, you can see it if I try and hold it where you can see it. But yeah, and so great idea, badly engineered, and in fact Coilcraft and all the other manufacturers do make high voltage versions of these coils. I don't know whether they're bought out subsequent to whoever the engineers that included these in the design, but they're cheap, but you know, not good at all, because yeah, it drives the power supply wild basically. So watch out for that. You can see there's a bunch of these here, look, here they are, little Johnnies broken down. The voltage was too much for them, and in fact on the data sheet for this one it doesn't even specify the voltage. So somebody thought, oh, I'll just use that, take the thing off the manufacturer's data sheet for the device, the active device that does the switching, and not bothering to really think it through. Okay, so they're bad. Okay, so look out for those. If you see those in a buck regulator circuit running off the mains with a low voltage DC output, suspect the coil, and if the semiconductor is blown up, It could be the coil sparking and blowing the semiconductor up. So you change the switching chip. For example, if I can find one here, is there one here? Should be one here. This is my graveyard. Is that one there? Yeah, that's one. That's the chip that's associated with these. So there's 3 of those, 4 of those, 5 of those. Can we see a pattern emerging here? I think we can. And then the LNK 302, 301, 304 chip is the culprit that gets blown up as well. And again, this is a buck regulator switch which is designed, you can tell it's got 1 pin missing. It's an LNK range from power devices. And that takes rectified mains, fires it through this. The internal FET does the work, a diode and a capacitor. Then you've got a 12, a variable offline supply, which is set by a couple of programming resistors. Okay. So LNK 301, 302, 304, not good. If you find it, it's probably duff. And there's another one that's one in a different package. That's another LNK, pin missing. If you see a chip like that in the power supply with that missing, check the DC voltage on the output of the smoothing capacitor nearby, because it won't be working. Probably. Not good. Not good at all, those things. Should be shot. Shouldn't be included. A very special shielded capacitor out of a, what was that? Rotor Schwartz generator, audio signal generator. Very right in the middle of the precision circuitry, and no capacitance on this one. The capacitance is gone. Special capacitor in its day when it was new. Yeah, especially in its day when it was in the 80s when it was made, designed, but you know, 10 a penny these days. Or most capacitors will have the same same performance. Interestingly, actually, if you look at this cap, the can makes up the negative electrode, and there's 1 pin in the centre. But if you take these caps, these are actually isolated. So you've got your plus and minus down here, but in normal circumstances, unless you've got a short, the can is not connected to anything. The can is isolated from the cap itself. So there's no electrical connectivity to the can unless there's a fault or leakage going on. Alright, so these aren't screened. Another one of those things. Another FET. Another FET. These little caps. See those? There are some dreadful versions of these. I don't know who the manufacturer are, but if you see these in audio amplifiers, your best bet if you're doing a service is to whip a few off. Just pick them at random, or if there's any in the Class D output stage, certainly have a look at those. The capacitance just reduces and reduces, and I think this one was about 14 microfarads or something, but I've seen the 10 microfarad ones, like this one. Is that 10 or 47? 10. 2 microfarads that was. So that had gone to 2. That one had gone to about 1/3 of its value. Okay, so if you see a board with these on and it's 10-15 years old, or even less perhaps, just do yourself a favour and take a couple off and measure them with a decent measuring tool, see that they've retained their capacitance, because you know, if all of them have gone a bit iffy, and when you find one, it's usually more than one that's gone on the board. It's down to the batch, and if you find you take a 10 off, for example, it's a good idea to take one of each value off. If you find one of the, say, a 10 microfarad one's gone, you can tell the rest of them are likely to have been from the same batch and in a similar situation. All right, so look out for that, because you know it's just not working right, just not sounding very good, and it's after the caps have lost half their value. So worth a check, can save a lot of time and trouble and put a new lease of life. I mean, most audio people know about changing caps, but these could be in a power supply, these could be in any piece of kit really, a computer or whatever. Just take a few off and check them, is my advice. Take it or leave it. Self-healing capacitors, Class X7 look, see those? Got some of these. These are interesting. Do you know what happened to those? These have got the power going through for switch mode power supply on a half bridge. All the power goes through these are at fairly fast rise times, 75 kilohertz pulses. And these capacitors, when they break down inside, they self-heal and makes a little pinprick, and the metal film just gets evaporated off and it heals itself, so which is very nice. But repeatedly, if you've got sparking going on or some kind of fault, these things will reduce and heal themselves away to virtually no capacitance at all. Okay, and some of the healing ones, yeah, look, you can see as it heals. If you unfurl this, I might take one apart sometime. If you have to split it open and unfurl it, you can see it's bulged up where it's been healing. You see this one's been healed itself so much that the scar tissue was split the underside of the capacitor, right? So always check these to, if you see these in a power supply and they're in series with a half bridge or full bridge, or in a Class D output stage, and there's power, i.e. being transmitted through them. I know it can't be DC power, but the AC power is being, energy is being transferred through the electrostatic coupling of the capacitor, which is what capacitance is. Then these will heal themselves away to zero. And you quite often get this problem as well when they've been used as capacitive droppers in cheap power supplies, where they use the impedance of the capacitor to drop the mains down to, you know, something to drive an LED, for example, in one of those cheap LED lamps. They heal themselves away to nothing. So self-healing capacitors are also self-reducing capacitors, and they've got a self-harm, self-ruination streak, X7s, right? So there's some of those. Power supply's not working. Bunch of fuses all been taken out by rogue power supplies. If you're into electronics and you want to know how to protect power supplies, read the data sheet on these fuses. It's quite shocking how much current they can take, because they are slow blow, because they have to survive the constant switching on, the inrush current, even though there's limitations. Sometimes there's a positive temperature coefficient resistor in there to limit the inrush current into the smoothing capacitors via the fuse, the filtering, and the bridge rectifier. But you know, it would be much better to have a normal 4 amp reasonably quick blow fuse and a little fuse holder like they used to do. Do you remember kit had fuse holders on the back so that when the fuse got tired, you could then just pop the fuse out, pop a new fuse in, and away you went again. But of course, you know, these days they don't want to do that, so they put a slow blow fuse in. But the trouble with these is they can sustain 10 or 15 amps for enough time to do a serious damage to electronics. So you can think of the fuse as not protecting the electronics really. The fuse is just simply there to protect the thing against fire and the safety, and also to make it fail after a nice period so this manufacturer can send you a new piece of kit. Internal fuses, complete waste of time, because they've uprated them and put slow blow ones in, and they don't protect anything. If you get a surge down the line, this is all destroyed. Your unit's gone, your FVTs are blown up long before the fuse actually breaks parts company. And this is what it does to your transistors. Look, see? Magic smoke has well and truly been released. Right? So that's that one. Fuses. Not good, internal fuses. Don't like them, never have. I think they should be on the outside, and they should be quick blow, or relatively quick blow. And otherwise it wouldn't do this to our poor components. Look, he's had his legs blown off. Not good. Right? What else have we got? What's that, 7384 or something? What's that? It's got no number on it, but it's, usually these chips are half bridge divider driver chips for power supplies, and also they're used in Class D high power Class D audio amplifiers as well. And they're, you know, components at stress, so they get blown up. We've got Schottky power diodes gone leaky. Right, so that's just a leaky diode in the power supply. Another fan chip, a whole bunch of small transistors. Quite often in the, see these things, SOT23s, they get distracted when the drive circuit. Often there's some Darlingtons and other drive in the gate drive circuits of the power FETs, and any transistors that are in the vicinity of one of those goes, gets like 200 or 300 volts up its shirt, and you can't often the trouble is they get damaged as well, and you can't really tell with a meter. But if you look at the scope and look at the waveforms carefully, it's good practice to change any drive transistors which are hanging around in the vicinity when the transient strikes, okay, from a transistor failing or from the power supply, mains generator or whatever. More power FETs from amplifiers. More of those. What's that? Yeah, divider chip, clock divider chip from a piece of test equipment. 74 series HC logic quite often goes, you know, you're looking through the circuit and you're looking for a divider or a flip-flop or a counter timer or a decoder, and the output's just not outputting. The logic signals are correct, nothing's coming out. And it's usually the output failed rather than the input of the device it's feeding into loading it, okay? Because if you've got the input of the device that's failed is loading, you can see some movement of the output, but normally there's just no output. It's like the bonding wire to the output pin has gone, or the output drive circuit has gone. So a lot of 74HC, 74ALS, LS logic gates. Can't remember where that was from, that one. That one's a mystery. Oh, if that comes back to me, I'll let you know. More power supply chips. Another LNK chips. Getting boring, isn't it, another one? Anything else interesting in this lot? Not really. Brick rectifier destroyed by mains transient. Not good, these GBL06s. Not good at all. I've seen quite a few of those fail. It's quite unusual actually when you open up the power supply, you think, oh, it's the FET's gone, but occasionally it's the bridge rectifier. Yeah, and that's about it really. So we've got various other FETs and small transistors, and some of these are ordinary Schottky diodes or normal high-speed switching diodes, iron 4148s in a different can, in a SOT23. Some of them are duals and others are singles, but these are usually used in switching circuits. This one is a flip-flop divider gate, you can see. That's out of a JBL amplifier. That quite often fails. That tiny little chip which is taking the clock for the Class D amplifier. Again, inputs are all there, no outputs coming out of it. It's been blown up. Varistor, gone. That one was, isn't any signs of any physical damage, but it was blown the fuse. It was broken down. As I say, they do wear out after a while. They denigrate over time, and the more you hit them, the worse they get. What else have we got here? Anything else? No, I think another capacitor. Look, another. What value was this one? It's gone fooey. Another 10 microfarad one, 16 volt. If you've got a 16 volt DC, I mean, I was taught at university was that you should use electrolytic capacitors near to their rated voltage, because if it's a 16 volt one and you use it say at 2 volts, then the capacitance can wander all over the place, and it doesn't like it that much. It can damage the capacitor itself by not having a sufficient voltage across it to keep it polarized. So obviously the space across the thickness of the insulating layer is designed so that the polarization voltage, which is the working voltage, is not high enough to break down that layer. But subsequently, if the voltage is too low and the electric field across that dielectric is not high enough, then certainly in the older days, I don't know if the new ones are available, still subject to it, but you get this problem where there's not enough voltage across to keep it polarized properly, so the capacitance starts to ebb away. So it could be on these that they're not just working at high enough voltage to keep the capacitance up. Okay, so that's not folklore. I was taught that. I don't know whether it's still true, but it certainly seems to me that the voltage, the value of these caps just ebbs away over time on certain ones. All right. What else have we got? Another fan 7384 half bridge gate driver, and then a whole bunch more FETs and regulators. So, what does that tell you? Power devices. Change one, change them all. Don't just change one if you've got a whole load of them in a unit. Alright, so I hope you found that interesting. That's last 6 weeks graveyard. That's the graveyard. Might give you a good clue about what you're looking for when you repair something. Oh, this one's an interesting one. This is a 10 ohm resistor in a amplifier drive circuit inside an active powered loudspeaker. Now if you look at the end of there, can you see the end of that wire is all sparked and arced? And this was in the, actually wasn't in the power supply, it was in the filtering circuit for the output for the tweeter. It was the Class D filtering circuit. It had this capacitor and a snubber, this resistor and a snubber capacitor. And the vibration from inside, it was supposed to be held with some silicon rubber, but you know, with the deep bass and 280 watt speaker, don't forget, this thing had just shaken loose, and it had a stress fracture on the end and had been sparking across. And in fact I noticed the output wasn't right, so I was poking around, I was seeing this strange effect going on with the waveform. And there, yeah, there she was. She'd cracked off that end, and I just got hold of it and just gave it a little twist like that, and it just came off in my hand. So when I put them back in now, I use supports on them, and I put some silicon jollop on there to support them properly, and mount them up against one of these like that, with some silicon jollop holding it, so it doesn't succumb to the vibration. But there's a mechanical vibration problem inside a powered loudspeaker, causing the amplifier to fail. And there's a lone transistor, look, high voltage switching transistor, just gone, leaky or blown. So that's my graveyard. Oh, and there's things like switching transformers from amplifiers as well. 200 watt switching transformer, 120 kilohertz, shorted turns, that kind of thing going on. So I hope you found that interesting. Bit of a rant, but if you want interested in the rest of the repair videos coming along, then you can see down the bottom right hand side of the screen, down that way, no, can't even do that. Now right down there in the corner is the subscribe button. If you could hit that, I'd really appreciate it.